Alright, so let's continue to the direct memory access. So, polling is alright, it works. But, for a device that does large transfer, uh, such as a disk drive, it seems like wasteful to use an expensive general purpose processor um, to watch the status bit and to feed data into the controller register one byte at a time. Remember, that's how polling works. We check whether there's free bit in the register, and if it's free, we transfer one byte, right? And we check again if it's free and transfer one byte, right? So if you're doing this is really not an efficient case to transfer a big file, right? Mm, uh, so there are other terms in to avoid one byte at a time for large movement. We call it program IO, right? Computers basically avoid burdening the main CPU with PIO by offloading some of this work to a special purpose processor called DMA, right? Direct Memory Access, right? So instead of having the computer, keep on checking, we take that job away. We have other processor, a special purpose processor that does this, and what it does basically to initiate a DMA transfer, the host writes a DMA command block into memory, right? So this block contains pointer to the source of a transfer, a pointer to the destination of the transfer, and the count of the number of bytes to be transferred, right? So a common block can be more complex, including a list of some source destination address that can be or not be continuous, right? So basically, you're doing the work of transferring a whole bunch of data, right, into memory directly, right? Now, in some cases where devices supports, the DMA or device controller supports the existence of virtual memory, then this would be even more efficient because it can read and put it directly into memory, and if there's not enough memory, put it, or the memory is busy, put it into the virtual memory first, right? So basically there are a couple steps in using the DMA. Basically the CPU device driver is told to transfer uh, some data to the buffer address X, right? And you know and in step 2 here, the device driver tells the drive controller to transfer bytes to the buffer at address X, right? So, and this is being done by the controller. It tells the controller that is the controller receives these messages and facilitate the transfer in a way, right? So next is the application interface. In the application IO interface, right? Basically, you know, IO system calls basically encapsulate device behavior in certain generic classes, right? So so there's some protocols are already implemented, and we want to hide these layers from the kernel itself, right? So how it's being done, that each OS has its own IO subsystem structure and device driver framework, and devices vary in many dimensions, such that a device can be a character stream or block stream. We're talking about hard disk and stuff. Sequential or random access, something like memory. Synchronous or asynchronous, we're talking about data like networking data, streaming data. Shareable or dedicated, speed of operation, read and write. So there's some things, variation that would occur here, right, for the type of device that you have, right? So if you can look at this, there's a bunch of controllers here. The protocol that you use communicating, I mean the protocol that they use to communicating to the kernel IO, the kernel. So the device itself is the hardware. Here's the hardware level, here's the software level, and there's a controller, and the controller works with the driver, and the driver works with the kernel per se, right? And we kind of encapsulate this so that things will work nicely. So if you have a new device, and you would just have a new device driver, right? So some of the we look here, we can look at the aspect variation and of those device and example of the hardware that we're talking about. So in data transfer mode aspect, we have a character block type of device dimension here, and we're talking about the disk. Access method can be sequential, random. We're talking about CD-ROM. A transfer schedule, this would be like tape or keyboard. Sharing would be tape or keyboard. Some device speed, we're talking about hard disk, talking about seek time, transfer time, and etc. Right? So, all right. So, some characteristics of the IO devices itself. You know, Broadly, IO devices can be grouped by the OS into the whether it's a block device, characters, IO stream, memory map, file access, or network socket, right? So in Linux, they separate that into this part of type of device. So usually we access the system through the kernel via a system call, right? And it will allow access to this device, basically. Okay, so so please read on about block character devices. Block devices mostly includes just disk drive, and it can be a raw IO, direct IO, and stuff. Sometimes there's a DMA, or most of the time there's a DMA controller attached to it. Network devices is one of it. It's a bit different from the block of characters. It comes data is basically comes into a buffer, right? And we have to see it as pipes, view, FIFO, or some kind of stream of data. Clock and timers, basically there's things that you can program that provide certain time on the computer, and it can also trigger some kind of interrupt into the system. Data can so most of the IO can be either blocking or non-blocking. When we say blocking, a process basically suspended until IO is completed, or non-blocking, IO calls returns as much as available, right? So you can blocking is easy to use, but if a particular kernel system is blocking, that means you cannot really, once it's being used, you cannot use it, and you have to wait it to be unblocked. But a non-blocking IO call system is mostly available, right? It allows people to interact with it. It's user implemented using multi-threading, right? So data can be asynchronous, so that means things can run at the same time while the IO is being executed. Okay, so the other parts of this we won't be covering, and it's not something we want to cover for the final for the semester, right? So we'll catch please read on the chapters all the way to in the book. Please read to the chapters where we talk about mostly about non-blocking and asynchronous IO operations. All right, thank you very much. I'll see you when we in some other time, right? Bye.